So, good morning. And later we will have the presentation by 3 groups. Group 4, 5, and 6. And in the future, same. I try to set the time, maybe if I don't mention explicitly. I expect you to have the short presentation. Why short presentation? Because we don't have enough time. All right. So at least if you have the limit time, so how you have the presentation, you should think about that one. If you are asked to show your result, of course, show your results first and then try to point out the important thing you want to emphasize. All right, so presenter from group 4, think about this, right? And 5 and 6 as well. And actually, I've seen the presenter, right? Presenter from group 4, 5, and 6. So later we will have the presentation directly. So presenter from group 4, come here. 这是收音，就这样抓着就好。然后这个是真的要讲，就这样。
其实前一组已经把讲得很完整。
没关系。So you can start.
Oh, okay. I'm from group 4. Actually, I think the next group has already explained most of the concepts covered in this question, so I just emphasize some important points. Let me see where the important point is. Okay, so I think the most difficult question for me is the question C, although it is a very easy concept, but it is related to the time the photo is taken. For example, if you make the time of the photo taken longer, and you will find this minimum value to be larger. Oh no, it's okay. Okay, so that's something I got from point C. So can everybody understand what I mean? I mean that the question mentions that the photo is taken per minute, right? Every minute they will take one photo. So we calculate it by 60 times 10, so we got 600. That's how we get this answer. However, if you make this time longer, for example, like 2 minutes, so the minimum value of x will be 10 times 120. Is that correct? Yeah, that's the only thing that I'll think about it. Anything except for this has been covered by the last group. So that's our presentation. Thank you.
Okay, thank you. And presenter from group 5. So you just use the content here, it doesn't matter.
Okay.
Okay, then you get back.
Touch screen, that's great.
Here, so choose yours.
I will not use mine because mine just have partial information.
Yeah, it doesn't matter.
Use this or this?
2 for 2. This one for the computer and this one for the audience.
Okay. The first question is about how do we deal with the packet size, the data, and we consider it as a whole packet. The all data considered is as a big packet, so we just calculated transmission delays of one line and multiplied by 3, and we got the answer of total transmission delay. And question B, we divided the data by 800, so we separated the data to 800 packets. So the one package will cost 10,000 data, and we divided by 2 milliseconds, 2 million bit per second. So we got the time of that line's transmission delay is 5 seconds, and we calculate the second pack delay to just add other 5 milliseconds, so it's 10 milliseconds. And C is that we use the pipeline sort of calculation method, so we calculate the first transmissions, that being 15 milliseconds, and we calculate the rest of the package, that is 799 packet, and times 5 because the transmissions delays, we got the answer and add them together, we'll get 4 seconds of transmission delays. D is about the pros of the method that we separate the packets into 800, to separate the data to 800 packets. That is, if you lost the packet on the way, it will not cause a big issue. And E is about the downside of it is you need to add more handlers to the packets and increase the data size.
Fine, thank you. So it doesn't mean we cover all the content, right? So for the presenter, you just try to emphasize the important things. And likewise for presenter from Group 6. Wait a moment. Yours. Yes. Choose yours. Okay. This one for this one, so you hold for the two. Something like that. It doesn't matter. You need to have two. This one for audience.
Okay.
If you want to use it here.
I'm the presenter for Group 6, and we need to find a S to let the total delay to the minimal, and we have to find the total delay first, and we use the formula by we learned from earlier class. We know total delay is this, and we can write the formula like this. So we need to find a minimal. So we need to find a critical point and find the first derivative of the formula and solve the formula. When the m is 0, the s is 2 square root 10f. So we know the s to let the total delay to be minimal. Okay, that's it.
All right, thank you. Good. So thank you. Well, let me mention this. You have a microphone, this one, for audience here, and also for the Sony camera. And because we have a streaming, so this one, the second one for the computer. And so that it will be clear for the stream video for the second. So in the future, maybe you should hold the two. All right. It won't be necessary to speak much louder. Normal volume, it will be okay. But I just don't know, in the future, you should hold the two. All right. And likewise for the presentation, yes, use my computer if you want to have some illustration. And next time, maybe I'll try to have this point as well. But this time, I have the traditional one, this one. All right, so next time, if you want to use some of them, let me know, and so that you feel free to use it. It doesn't matter. All right, so this is the presentation by all of you. And right now, let me switch back to our PPT slide to have the solutions. So later, specifically, I try to emphasize each group to focus on your answer, correct or not. All right, group 1, 2, 3, and 4, 5, and 6 for each problem. Okay, so that means switch from the current one to the PPT slide to that you have the solutions. So first of all, this is the solution of problem 1. I think some of you at least from good one, some of you take a picture and later you can have the checking with your members. Solution to problem 2. Of course, for all of you, you can have the photo for each solution. And the solution to problem 3. Well, solution to problem 4. Next one. Sorry, so okay. Smaller, right? You can come here. I'm not sure. But later, let me take a picture. So wait a moment. I think the problem here perhaps because of the solution of the projector. All right, in the past, I ever have a problem like this. So it's not the problem of my computer. In fact, different resolutions. So finally, we have some problem like this. So let me mention this. Even for me, it's hard to tell. But A is 12, B is 5, C is 4.01, and D maybe some discretion. So almost the same as yours. Okay, almost the same as his. So you can check the solution from group 5 because this one still okay. So take a photo. In fact, same as the solution provided by group 6 as well. Right? So right now I already have 2 minutes to have the discussion for each problem within the group. So check with your members. Everything's okay or not okay? And later, I prefer to ask you to have the reflection. At least you can have the reflection for your own problem, right? So let me interrupt you. So after now, we think about your problem, right? Group 1, problem 1, and group 3 and 4, problem 3, right? at least you emphasize your problem first and think about regarding the problem, illustration, and solution. At least focus on your own one. And if you still want to have some possible comment on the other problem, sure, you can mention as well. All right. Perhaps you think, well, I emphasize problem one, how about the others? Well, at least you have a solution. And also maybe you have some derivation by the other groups. So feel free to check partly, right? And so that you can have some possible reference for the other problems. So that's why I let you have this. Even you just focus on one problem, still you can check the others. All right. And maybe you think, oh, it takes time. Why I still ask you to focus on the problem? Because I push you to think, right? And so you won't fall asleep. Am I right? At least you have something gain. So this is my purpose to have this kind of activity. All right, so let us have the reflection first. Same, 2 minutes. Check it, is it okay? Or maybe I should switch to a different one. So check this, is it okay? Can you see the current problem on Paul Aviquel? Yes or no? Oh, okay, so let me switch. Later we will have an attendance check-in full today. So this one, 2 minutes, go. Next time, if you want to have the app, you can download Paul Aviquel and so that you can have the problem directly. And it won't be necessary to scan the QR code because you will already have the alert. So you cannot skip group ID, name, student ID, and then you need to have the summarize. If you still have something you're not so familiar, let me know, and so that later I can check them.
Write about just about one problem.
At least you are.
Yes.
Yeah, at least.
Thank you.
Actually, I have 1 more minute to that you finish the answer. All right. And at least focus on your own problem, because you don't check the other. So at least focus on your own problem. So let me make sure not finished for your answer. Yes, okay. One more for you. All right, so let me check quickly any possible problems here. So here we have some discretion. It is okay. Well, after now, I think you have your own reflection. That's okay, no problem. But let me get back to the solution again. So about this problem solution here, I think it should be okay even you are not the member in group 1, right? Am I right? If so, then you can refer to this. Let me go to the next one. And for this, is it okay? But let me check. Problem 2 from group 2. Everything's okay for the answer of this problem? The presenter from group 2? It's okay, right? So this one, it can be understood by you if you can go through this. So anyone want to ask me to go through the solution for problem 2? I assume you can read it. So let me go to the next one. Here, this one. You see? Presenter from group 3 and 4 here. Why over 60? Because per minute, right? Per minute. And if so, then I think everything will be okay, right? This one, it's per minute. All right, and just set this one to the capacity. Then we can find the value of x. So I have the supplement to that one. Well, for this, I think right now, even for me, sometimes it's not so easy to read. But this one, I think I will send the solution to you later. You can check it later. And if yes, we need to get back to the solution to that it have all the detail, I will get back to this one. But I will release the solution to you later, and so that you can have the details, the detail of the problem. And at this moment, I think even I want to take a picture, it is not the good resolution. So let me go to the next one. And this one actually is correct. And actually, previous problem and the current problem just follow the step of the presenter from group 5 and 6. So if you want to have the direct solution to problem 4 and 5, right now you can refer to Padlet to check answer from group 5 and 6. If indeed you want to check it immediately. I check almost the same. All right. So this is the activity 1. Talking about 5 problems selected from chapter 1. And we still have the remaining problem for the self-exercise. So I still expect you to go through some of the problems so that you can have the exercise there. And so that you can prepare for our quiz. Our first quiz is scheduled to 7th week, right? So be attention, you should go through the problem set of self-exercise. And also if I have some specific discussion in class, sure, you should notice those, and so that you can have the proper preparation to quiz, our quiz. The first quiz is scheduled to 7th week. Just follow my schedule. So,
may I ask when will the quiz take place? So
7th week. Yeah, maybe Monday or I will check it. Yeah, I will check it. Possibly if we don't have enough time, maybe I set it to Wednesday. Yeah, because we may have a bit delay. All right. So if you think you want to have the preparation, you think it's Monday, possibly I may use Wednesday to have the quiz. How long we have the duration for that quiz? I will set it to 20 minutes. 20 minutes. 2 problems possibly. Someone like, okay, we have 2 problems like these. So 20 minutes. All right, so this is the actual discussion about the possible quiz in week 7. Well, we finished this. So next one, I ask you to have attendance checking. Well, this one, can you see this? Is it okay? About the current attendance checking? Yes, right? No? Okay. So let me make sure, not finished. Okay. You still have 15 seconds. All right, let me check again. Oh, okay. Then I have 1 more minute. As I remember, Deborah joined online today, and I've seen the record for her. So it's still okay if sometimes you cannot attend the classes by attending the by coming to the classroom. I think you still can consider to join online using our YouTube channel. So let me check again. Everything's okay? Okay. So let me move on to the next one. So after the flipped classroom style to chair principle of network applications, I still want to remind you of this. If you fail to chair the flipped classroom video, I suggest you to go through that one. It doesn't mean you need to go through slowly. You can use your way to go through that quickly. And after that one, why not data check web? Well, maybe you have a question. Web, it's so easy. Well, data check. Of course, for some, they are easy. Maybe some not. But before that, we already have the short description about our terminology regarding to the later discussion. So first of all, web. We try to draw your attention to relate web to object. So later we will call object instead of web page. So object including web page, including, for example, image and something else. So all we call objects. All right. So the initial one, we have a name. It's the base file. For example, index, it's the base file. All right. Within the base file, then we will refer to the other objects. And actually, we have a hyperlink here. So it's a file, right? So actually, you can have the concept, we have a file. Even it's the image or something else. So we can have the file. And all the files here, later we call them objects. Well, for the protocol, HTTP itself, we have the expanded terms, hyperlink transfer protocol. So hypertext transfer protocol. So that says we have HTTP. And the HTTP, it's a web, so we have a TCP. Because of a TCP, we need to have the connection. All right, connection establishment. So we have the connection. And so that we should have a connection-oriented model by using TCP. All right, so we have the connection requested by the client, and the server will accept the request. So like this, send the request and then accepted by the server. And so that we can have the other to have the similar connection establishment. And after that one, in fact, we need to send the object to the client because the client requests the web page. So this is the idea behind HTTP. And later we will use that idea, but let us mention this one. HTTP, previously we have some way to consider why we want to use TCP or UDP. Here, because it's text and it should be correct. So we should have the reliable service. That's why we choose TCP. And the TCP here, you can read all the description, client initiate TCP connection, fine. But port number associated with the server is 80. All right. Server, the port number associated with the server is 80. And then port of a client. What's this? Actually, it's unknown. The unknown port number set by the OS of that client. So think about this. Here, it's server. Server, we have 80 port number, but it's me, I'm client. The port number for me is X. The X assigned by my OS. Is it okay? So in fact, we have a pair, but the pair 80 for the server, not 80 for the client. Actually, it's a known port number, but the unknown port number will be assigned by the OS of the client. Client process will determine the port number for client. Well, of course, you can see accept, all right. And then we will have the message exchange. So here we have a message exchange. And then we close the connection. And later we want to have some details how we have the connection. Maybe single connection, multiple connection, or something else. Later we will mention that one. But HTTP is a protocol. What kind of protocol? It's a stateless. Stateless here that says we don't want to keep the stat for the client. So server maintains no information about past client requests. No burden for the server. So it's stateless. And what's a stateful? Stateful protocol. Stateful protocol, yes, the server should keep the state of the client and client requests. If so, that is the stateful protocol. Currently, HTTP is a stateless protocol because you won't want to have the burden. So HTTP is designed to be a stateless protocol. Well, about the current description on this page, it should be okay, right? All right, so let me move on to the next one. Well, I let you know, we should have the detail one connection, multiple connection, because we should have the version. The first version, non-persistent. Persistent, what that means? Normally, if it's a course about teaching EMI courses, the lecturer will ask us to guess, or maybe. So we will let you know, okay, what's the meaning, and ask someone to mention that one. But for me, that's okay, this one. All right, so if know the reference here, then non-persistent, that says, I don't want to request, insist to request the next one. So it's the non-persistent. If a persistent first one finished, then I need to have the next one. So the two versions like this. Well, is it true? Like some description I mentioned, you see, non-persistent TCP connection opened, and the second item, at most one, just one object sent over the connection. After that one, okay, finish. However, for a web page, only one object, normally no, right? So we should have the next connection and next connection. So for non-persistent HTTP, we should have multiple TCP connection. All right. Or otherwise, we cannot finish the transmission of the web page. Well, it says downloading multiple objects required for the multiple connections. Well, we emphasize this. However, for persistent, if I have the base file, I know how many connections I will have the multiple object transmitting. And so that once finished, then I close the TCP connection. So it's just a single connection, TCP connection. All right. So multiple connection and single connection. Which one will be efficient one? You can guess which one will be efficient one. Single one connection or multiple connections? Of course, single one, right? However, at least we should base on this so that we have the possible details for the non-persistent HTTP and the persistent HTTP. Well, we have the illustration. Of course, we need to have a connection establishment, then send me the file. But for non-persistent, send me the file one by one. One by one, finish, and then we need to continue to have a next one, next one, next one. All right. So right now we have the connection connection establishment. Here maybe we have the round trip time. We can have round trip time. So we have RTT. So 1 and 2nd, so we have 2 RTT to serve as a possible time duration for connection establishment. As for the file, I request same 2 RTT as well. But here we have the file. We need to have the transmission. Right? So we have a transmission delay here. Well, right now, think about this. Why I have a slant line from client to server, server to client? Because this indicate RTT indicate at least the propagation delay. At least the propagation delay, and at most the delay of propagation, queuing, and processing. So about the RTT, excluding the transmission only. All right, so it's really important. Even I cannot have the direct message for you on the page. RTT excluding the transmission delay and including the remaining delays. So let me mention some in Chinese. 这个 RTT 就是不包含 transmission delay， 但是其他的3个都可以包含。有听清楚哈？ So we have the RTT, and because we exclude transmission delay, so that's why we have transmission delay for the object. So currently I have a hint. If I just transmit one object, we have 2 RTT for the connection establishment and 2 RTT before the transmission of that object. However, if you want to include the time for that file, you need to have the extra time. It's the transmission delay for that object. And we can have the remaining one, right? You see, we have the remaining one. For example, right now we have the possible assumption. We have 1 index file and 10 objects. And so that finally, if we follow this one, of course, you can use my way to have the time diagram. And based on time diagram for the first one, how we have the delay calculation, and right now include the others, so that we have this result. Total delay, it should be 11 multiplied 2 RTT connection establishment and 2 RTT plus the transmission delay. Assume we have the common size for the object. So finally, we should have 4 RTT plus the transmission delay multiply 11, because we follow the current story, 1 index file and 10 objects about the current version, non-persistent HTTP. We have the total delay, follow the current form. It should be okay, right? All right, so we will have the derivation for a different version. And also I try to have some enhanced version for non-persistent and persistent. And also we have pipelining as well. So later we will have variants of HTTP. All right, that's all. Let me stop here. And before we dismiss the class, let me make sure. Any questions? If no, see you next week. Okay, bye-bye.